All right, number 6. So this is the long one, essentially. Uh, it's the general idea of this one is talking about random assignment and showing why sometimes you really need to be a little more specific than we just randomly assign, because you can do it wrong in ways that isn't actually helpful. All right. Consider an experiment in which 2 men and 2 women will be randomly assigned to either a treatment group or a control group in such a way that each group has 2 people. The people are identified as man 1, man 2, woman 1, woman 2. The 6 arrangements are shown below. 2 methods are being considered: the sequential coin flip, that we'll talk about in part A, and the chip method, that we'll talk about in part B. For each method, the order of assignment will be man 1, man 2, woman 1, woman 2. For the sequential coin flip method, a fair coin is flipped until one group has 2 people. An outcome of tails assigns the person to the treatment group, and an outcome of heads assigns the person to the control group. As soon as one group has 2 people, the remaining people are automatically assigned to the other group. Alright. Complete the table below by calculating the probability of each arrangement occurring if the sequential coin flip method is used. Okay, so essentially, we're going to go through these arrangements, and see how we would have to flip coins for them to occur. Alright, so this is our method, our order. Man 1, man 2, woman 1, woman 2. Alright, tails goes to treatment. T, T. Okay, cool. So man 1, man 2. So this is 1, and this is 2. That means we flipped tails, tails. And then, after we flipped tails, tails, this group was full, and so both of the women were assigned to this one. Arrangement B. We flipped tails, heads, tails. Alright, this is our order. Man 1 went to treatment, man 2 went to control. So that's T, H, T, T, H, H. So T, H, H, T, H, H. Alright, here we flipped heads, heads. So that's heads, heads. Here we flipped heads first, then we flipped to tails, then we flipped to heads. So that's H, T, H. And in the last one we flipped H, T, T. Alright, our probabilities. Each of these has a 50% chance of happening, so this is 0.25, or 0.5 times 0.5, which is 0.25, or 1/4. We'll just do that. Each of these has a 50% chance of happening. That's 1/2 to the third, that's 1/8. 1/8. 1/4. 1/8. And 1/8. Alright. For the sequential coin flip method, what is the probability man 1 and man 2 are assigned to the same group? Where does that happen? Here and there. The probability of each of those, that's group A and D, so that's 1/2. I'm doing this now because when I scroll down, I think it's going to stay in the same spot. Yeah. Alright. 6 arrangements are repeated below. Okay, so we're going to draw on there. For the chip method, 2 chips are marked treatment and 2 chips are marked control. Each person selects 1 chip at random without replacement. Complete the table below by calculating the probability of each arrangement occurring if the chip method is used. Alright, so same thing, we're going to draw up top there. Alright, so man 1 goes first, man 2 goes second. This has a 2 out of 4, right? I gotta change my pen size. And then man 2 is drawn second. Now, there's only 1 chip left and there are 3 chips remaining. So that has a 1/3 probability. And then, like, all that's left are control chips, so that's going to be 2 out of 2 and 1 out of 1. All right, arrangement B. This is going to have a 2 out of 4. Like, we're always going to start with that. The first person always has a 50-50 shot. And then man 2, there are 2 control chips left and only 3 chips, so that's 2 out of 3. And then for woman 1, who's our next one chosen, there are 2 chips left, a treatment and a control, so the probability she gets treatment is 1 out of 2. Alright, man 1, so this is 2 out of 4. This one is 2 out of 3, same as it was before. And then we have 2 chips left to treatment and control. The probability that woman 1 gets control is 1/2. Alright, this is going to be 2 out of 4. And then this is the same as there, right? It's 1 out of 3. Here, man 1, 2 out of 4, and 2 out of 3. And then woman 1 will have 1 out of 3 that she selected, or 1 out of 2, sorry. 2. Man 1, 2 out of 4. Man 2 is different, so that's 2 out of 3. And then there's 2 chips remaining, so it's 1 out of 2. 2/4 times 1/3 is 2/12, which is 1/6. 2/4 times 2/3 times 1/2 is 4 out of 12, 24, which is 1/6. 2/4 times 2/3 times 1/2 is 1/6. 2/4 times 1/3 is 1/6. That stuff is the same as there, it's 1/6. That stuff is the same as there, it's 1/6. So in this one, each of our arrangements has an equal probability, which is kind of useful. For the chip method, what is the probability that man 1 and man 2 are assigned to the same group? I mean, the groups are the same, so it's going to be A plus D. It's going to be 1/3. All right, 16 participants consisting of 10 students and 6 teachers at an elementary school will be used for an experiment to determine lunch preference for the school population of students and teachers. As the participants enter the school cafeteria for lunch, they will be randomly assigned to receive one of 2 lunches, so that 8 will receive a salad and 8 will receive a grilled cheese sandwich. The students will enter the cafeteria first, and the teachers will enter next. Which method, the sequential coin flip method or the chip method, should be used to assign the treatments? Justify your choice. All right, so it's going to be the chip method. That's just right? Like, all of these are equally likely. Whereas with the coin flip method, they were not equally likely. The problem here occurs when, because the students are entering first and the teachers are entering next, that the coin flip method makes it more likely that all the teachers get the same lunch. Which is a problem if teachers and students have different tastes. Right, so when we went up to A, part 2, you saw that there was a 50% chance that man 1 and man 2 were assigned to the same group, whereas here there's only a 1/3 chance that man 1 and man 2 are assigned to the same group. Because, like, the coin flip method, you could get all of the students having one of the lunches or the other one, and that will bias it if they're different. Basically, like, the chip method, it changes the odds each time, right? So if I've drawn 4 students onto salads, I'm less likely for the next student to get a salad. Whereas on the coin flip method, if I've drawn 4 students having salads so far, and the first 4 students, the 5th student is just as likely to draw salad. So that it's that kind of escalating odds or de-escalating odds, however you want to think about it. That makes the chip method better because they're more evenly distributed across the 2 groups. Now, if you had randomly assigned the order that they were entering the cafeteria in, it wouldn't matter. you could do whatever you wanted. Honestly, if you'd randomly assigned the order they were entering the cafeteria in, you could give the first 8 salads and the second 8 grilled cheese sandwiches, and it would be just fine. So if you mess up your randomization there, it doesn't matter because you did your randomization earlier. Now, if you did that wrong as well, that's a problem. But, yeah.